All right, guys, this is your second lesson, and it is about functions in context. So functions have a role in the real world. Let's get right to it. So a function describes relationships mathematically, predicts behavior. It helps us think about the real world numerically. And really, we're looking at patterns. We're looking at how quantities change within the relationships. I want to remind you guys that a function is a relationship between two quantities where one input has exactly one output. All right, so we're going to be able to tell today whether something is a function or not and how to use it in context. Okay, so here's a contextual situation. All right, so it says Fran collects data numbers on the number of feet she can walk each second, and she comes up with a rule. All right, when you hear the word rule, we're really talking about a function's equation. So the equation is this: d of t equals 4t. All right, and we're going to ask 4 questions, seeing if we understand function notation. So the first question is, what is Fran looking for when she writes d of 12? Second question, what does it mean when we say d of t equals 100? Third question, how can we use function notation to say Fran walked 16 seconds? And last, how can function notation be used to say that Fran walked 200 feet? All the answers are below. First of all, when we look at d of 12, look at where the 12 is. The 12 is in place of the t, meaning that 12 is time in seconds. So it's important for us to know what's our input, what's our output. 12 is an input. The input is 12 seconds, which means that our output needs to be distance in feet. All right, how do we find that? Well, we evaluate. So we take 12, multiply it by 4, and we get 48. So 12 seconds input, 48 feet is the output. All right, looking at problem B. What if we don't give the input? What if it says d of t equals 100? Well, in that case, you don't have the value t, which means you don't know how many seconds or what the input is, but you do have the output. The output's 100. All right. The way you set up this problem is you say, well, the function, let's set the function equal to 100. So 4t equals 100. You remember that's a one-step equation. So you divide both sides by 4 and you get t equals 25 seconds. All right. Problem C is similar to A. If Fran walks for 16 seconds, what is that? How can you write that in function notation? Well, you're going to say d of 16. You're going to put the 16 in the parentheses, and you're also going to substitute it for the t in 4t. So you're going to say 4 times 16, and you're going to get 64. So d of 16 has an output of 64. In other words, 16 seconds, 64 feet. The last one tells you 200 feet. You can work backwards, divide by 4, and you'll get 50 seconds. It's important that you know that 200 does not go in place of the t, right? It's d of t. So it's the distance depending on time. All right, 200 is a distance in feet. All right. In the next video, we're going to talk about another function in context, which is a pay-as-you-go plan. All right. But right now, to sum up this lesson, every function has an input and it gives you exactly one output. We need to identify in every contextual situation what is the input or independent variable and what is the output or dependent variable. Also, we need to know where those go in the equation. Inputs go inside of the parentheses, or they go in the variable. For example, here my input is going to go in t in your input variable. All right. Outputs are the result after you have multiplied things out, after you have carried out your algebraic operations. All right. The output is the result once you've used the input. So that is how you use functions in context. Right. Another interesting thing that you're going to talk about, that you're going to look at today, is how can I very quickly look at a situation and know if it's a function or not? Well, you remember one of the first things that you learn is to be a function, one input maps exactly to one output. So take a look at some of these and you judge it by yourself. I'm not going to give an answer key for this yet, but I will say, for example, when you look at this first scenario, every input has a different output. Right? But if you look at the scenario right below it in cell number 5, you see the input of -2 has 2 different outputs, +1 and +2. So you want to make sure you're able to tell. Look at this diagram, for example, in cell number 6. The input 0 gives you 2 different outputs. That's like pushing a button in the vending machine and it giving you one of 2 different things. So that's not functional. All right? So you would rule that this one, for example, is not a function. So that's just something for you to look at. I encourage you, anytime you're watching these videos or completing any work, do so in your notebook, take notes, and it'll go a long way. All right, so that's the end of this portion of the lesson.